All right, so the question we have here says 3 vectors, 3 meters per second, north, 45 degrees west, 12 meters per second west, and 5 meters per second act at a point. Calculate the resultant of the vectors. This is WAEC 2011, number 11 theory. All right. So to solve this question is about vector. This question is about vector. So for any vector question, before you start solving, you can just draw a cardinal point. Just draw a cardinal point. And the cardinal point is this, showing the directions. Up here is showing the north. Right-hand side is showing the east. Left-hand side is showing the west. And down is showing the south. Now, 3 vectors, the magnitude, every vector must have magnitude and direction. The magnitude is 3. This is the direction. The direction is northwest. Northwest is between north and west. So this will be the vector. Northwest should be this, 45 degrees. Remember, from north to west is 90. So 45 should be half of it. From north, you covered 45 to west. So from north, it covered 45 degrees to west. And the magnitude is 3 meters per second. So this is it. 12 meters per second west. 12 meters per second west. So west is just this now, or due west is this. So, but because it is 12 longer than 3, I will need to extend this line so that it will be longer, because the magnitude of west is longer than. So I can do this and call it 12 meters per second west. Put the arrow. Next is 5 meters per second south. 5 meters per second south. South is down. So as you can see, down, south. South down is 5. Is longer than this 3, but shorter than 12. So let me readjust. I can use this. Now they say we should find the resultant of these vectors. How many vectors do we have here? We have 1, 2, and 3. So what are we going to do? We use the method of resolution of vectors. So resolution of vectors, first, I am going to resolve this diagonal vector into vertical and horizontal components. That's what I'm going to do. So I think this is the only result, the direct diagonal or the resultant that we have here. So I will resolve this into vertical and horizontal. Then I can now find the resultant vertical, resultant horizontal, and finish up. So what am I going to do? Draw this line again. Okay, no. Let me present it the way you are going to answer the question. Let's say you are writing your WAEC examination. So how do you present this? You are going to resolve this into vertical and horizontal components. So you're going to write the vertical component. But I'm going to draw this to show you exactly what I'm doing. So remember, the vertical component of any vector is given by any vector r, any resultant vector r, that made an angle theta to the horizontal. If, for example, you have this is a resultant, a vector r, and the angle it made with the horizontal is theta, to find the value here, whenever you are bending an object, object that is diagonal, and you want to make it stand, you are finding a vertical component, because this object that is bent this way can be made to be horizontal and it can be made to be vertical. So when I make it vertical, I have found the vertical component. When I make it horizontal, I have found the horizontal component. And if this will be the angle it made with the horizontal, the vertical component will be, use this value here to times sine of the angle. And the horizontal component here is, use the value here to times the cosine of the angle. So vertical component is r sine theta, and horizontal component is r cos theta. So vertical component of this 3 here, which will be written here, is equal to 3 sine angle that it will make with the horizontal. But you notice that this angle 45 here is made with the vertical. So this is the angle that I will need. But you know that if this is 45, here also is 45. So the vertical component, which I'm going to write here, when I will make this line here to stand. Sorry. So when I will make it to stand, it's going to be 3 sine 45. So the vertical component will be 3 sine 45. That is 1. And the other one, remember we have a vertical component, another vertical value here, 5. So I have 5 here, I have 3 sine 45 here. Okay, then the horizontal component, if I will press this, because any diagonal has vertical and horizontal. So the horizontal component here is going to be 3 cos 45. But already, remember that we have 12 written on the horizontal. So what do we have here? 12 plus 3 cos 45. That will give us the horizontal component here. Okay? Horizontal component, vertical component. So what are we going to do now? This is 3 cos 45, 3 sine 45. This is 3 cos 45 plus 12. This is 5. Nothing here, nothing here. So here is 0. So how do we now resolve the total vertical? The total vertical component will be the difference between all the vertical. This is like vertical up, and this is vertical down. So subtract the two to get your vertical component. So what am I going to do? Use any one to subtract the other. So I can use this to subtract this. We are going to have 5 minus 3 sine 45. If you like, you can do 3 sine 45 minus 5. At the end, you are going to get the same answer. Okay? 5 minus 3 sine 45 will be the vertical component. That is up, down. Now the horizontal component. The horizontal component is going to be this and this, right and left, so which will be 12 plus 3 cos 45 minus 0. So with this, we can solve 3 sine 45. Sine 45, okay, is same as 1 over sub 2. So let me work on that. So my vertical component here now, so we have only one vertical. Now, for the answer to this vertical, we represent vertical, and we have only one horizontal. Okay, so with this, we have only one vertical and one horizontal. So the answer here will be written here. The answer for the horizontal will be written here. Then we can now find the final resultant using the Pythagoras theorem. So that is what we're expected to do here. So vertical here will be, the vertical component will be 5 minus 3 times 1 over sod 2, because sine 45 is 1 over sod 2. Okay? Okay, let me see if I can just do that. Okay, no problem. We're going to finish up. And horizontal component, is going to give us 12 plus 3 times 1 over sod 2 again. Sine 45 and cos 45 will give us the same thing. Okay, so with this, we are going to have 12 is. So if we use our calculator here, do I have my square root here? Do I have my square root here? Okay, yes. Or I have my sine and cos. So I can just go straight and press cos 45, 3 times cos 45, 3 times cos 45. Okay, that will give us 2.12 times, okay, sorry, plus 12. So my answer here for the horizontal would be 14.12 meters per second, and the vertical will be 5 minus 3. So when I do minus 12. Okay, if I will do 5 minus 3 times 1 over sod 2, that will still give me minus 5. So my answer will be 2.89. Vertical will give me 2.89. So you can see that if I will draw this, my vertical component will be 2.89. Horizontal component will be 14.12. We can now find the final resultant using the Pythagoras theorem. R squared is equal to 2.89 squared plus 14.12 squared. R squared will be 2.89 squared is going to give us 2.89 squared. There's no square, let me times 2.89. That will give us 8.35 plus 14.12 times 14.12. That will give us 199.37. 199.37 plus 8.35. So when I add it up, I'm going to have R squared is equal to 207.7. So R is now going to be square root of 207.7. So when you do square root of 207.7, you are going to have 14.41. So our answer for the resultant is going to be 14.41 meters per second. All right, so we move to the next question quickly. It says two strings, each inclined at an angle 30 degrees, two strings, inclined at an angle 30 degrees to the horizontal, are used to hold a bucket of water weighing 20 Newton. Calculate the tension in each string. Okay, so what are we going to do here? We have a bucket of water. Solution. This question is about equilibrium. It's about equilibrium and triangular forces. So if we have, let's say this is a bucket of water, and we are going to use two strings, and the way we are going to be pulling the string will be in such a way that the strings will make angle. The strings will make angle 30 degrees to the horizontal. I'm pulling this way, such a way that someone is pulling this way, someone is pulling this way, and the weight of this bucket is dragging it down. So making it three forces acting on this bucket. Okay? So let the tension on this string be T, and here T also. So they said calculate the tension. I can call this T1 and call this T2 acting on the string. So what are we going to do? Since we have three forces, we are going to make use of the law of equilibrium that says that if three forces will act at a point in a body to make that body to be in equilibrium, that they can be represented both in magnitude and direction using the sides of a triangle taken in order. That is, you get three forces acting on a body, that we can use these three forces now to form a triangle. And that's all. From there, we can get the value of each force. So we are given the force, the weight, the one that is dragging it down, 20 Newton. So we don't know these ones now. Now, what are we going to do? What are we going to do? We convert this to a triangle. Okay? So looking at this, I can start from anyone. Let me start with the downward force. Okay, downward force. I will go down. This force is down. After the downward, can I move this way? The next is T. T moves. This is T, the first one. Let me call this one T1 and T2. Now the next one, can you see? If you watch this direction here is between north and east. And this direction here is between north and west, this particular direction. And this one is south. So I'm going to draw northwest from here. Okay. So I'm going to, this will give me northwest. Now, how are we going to represent the angle? Remember that the angles were made with horizontal. So I can create, I don't have any horizontal line here, so I can just create a horizontal line, maybe here. Okay? So that if this is, or if I like, I can create the horizontal lines here. So you see that the angle made by T1 with the horizontal is 30. Angle made by T2 with the horizontal is also 30. So can I put 30 here, which is the same thing as this now, because they are alternate. So here also is 30. This is 30, this is 30. So making the total angle to be what? 60. So I will call this T2 and this T1. And this one downward is 20 Newton. Okay. So, and you know that if this line and this line, they are 90, if this is 30, here is going to be what? 60. Okay? And if this also is 30, here also is going to be 60. And 30 plus 30 here will also give us 60, suggesting that this triangle is what? An equilateral triangle. If this is 60, this is 60, this is 60, it means that all the angles are equal. And if all the angles are equal, all the sides are also equal. So if this is 20, it means that here is going to be 20, and also that this is going to be 20 Newton. Okay, so with this, we have solved the question already. Now my angle, the tension on each string is going to be 20. I said, if we discover that here is 60, this is 60, I hope you know that it means that these two sides are equal. Okay, and if this is also 60, it means that 1, 2, 3, they are equal. So which means if this is 20, here will be 20, and here will be 20. So no need for solving. But if maybe two sides are equal, or maybe the three sides are not equal, to solve for each side here, you are going to make use of the sine rule. We can still apply the sine rule here, but no need, unless we have another question that will not involve the sine rule. So after making this diagram, you can write, since the triangle is equilateral, so it means that T1 is equal to T2, which is equal to 20 Newton. Simple. All right, so we move to the next question. Two forces, 3 Newton, 4 Newton, act on a body in directions due north and due east, respectively. Calculate their equilibrant. Equilibrant. Take note, there's a difference between equilibrant and resultant. Equilibrant is that single force that will balance all other forces acting on a body in equilibrium. That's equilibrant. A resultant is that single force, okay? That single force that is formed by combining two or more forces together. The result of combination of forces is equilibrant. But the force that is balancing other forces is equilibrant. Sorry, I said the result of the combination of forces is resultant, but the force that will balance every other forces is an equilibrant. Okay, but there's one thing you need to know between resultant and equilibrant. If you are asked to solve for equilibrant, you will need to, first of all, find the resultant. Then you make use of this fact that resultant and equilibrant are equal in magnitude, but opposite in direction. They are equal in magnitude, but opposite in direction. That is, if resultant is 5 Newton, equilibrant is 5 Newton. But if the direction of resultant is north, due north, equilibrant is going to be due south, because south is the opposite of north. So let's solve this question. Two forces, 3 Newton, 4 Newton, act on a body in these directions, due north and due east. Just like I told you, draw your cardinal points. So draw north, up, south, down, east, right, west, left. 3 Newton is due north. 3 Newton here. 4 Newton is due east. 4 Newton here. So, since 4 is greater than 3, I'm going to extend 4. to be longer than 3. Calculate their equilibrium. Just like I said, you will need to find their resultant. So how do I find their resultant? Complete this diagram. So if this is 3, here will be 3. If this is 4, up here will be 4 as well. Now draw your diagonal. The diagonal between their common point. This should be their common point. These 2 points. So draw. This will be the diagonal. So the diagonal will be R. Call it R, the resultant. So that when I find this resultant, I can find the equilibrant and also the direction. So what is the direction? The direction will be this particular angle. Remember that it moves from north to what? To east. So it covers this angle trying to move from north to east. So if I can find this angle, that will show me the direction between north and what? East. Okay, so let me find the resultant first. Cut out one of this triangle. Cut it out. Here is going to be 3. This is going to be 4. And this is going to be our R. Pythagoras theorem. Okay? So we have it that R squared is equal to 3 squared plus 4 squared. R squared is equal to 9 plus 16. R is going to be square root of 25. R is equal to what? 5 Newton. So since the resultant is 5 Newton, what is going to be the equilibrant in magnitude? You answered correctly. The equilibrant is going to be 5 Newton as well. So E is 5 Newton. So the magnitude is 5 Newton. Now we need to get the direction. So how do we find the direction? Just like I said, the direction will represent this particular angle, not this particular angle east. It moved from north to east, covering this angle. So you can see this should be the bearing. So can I just cut out this? Cut it out. So that once I can find this angle, this particular angle here, I am done. So here will be theta. This will be my R, vertical. This will be my 3, horizontal. This will be my 4. We know R already now. R is 5. So we can use any of the SOHCAHTOA, if you can remember the SOHCAHTOA. So if you apply the SOHCAHTOA, I think I want to use sine. Let me use sine. Sine is opposite over hypotenuse. So between these two, which one is the opposite? Opposite to this angle is 4. Okay, so opposite over hypotenuse, sine theta is going to be 4 over hypotenuse 5. Sine theta is going to be 4 over 5, is going to give us 0.8. So theta is going to be sine inverse of 0.8. Theta will now be, so what will be the sine inverse of 0.8? Calculator. Okay. My sine inverse, do I have sine inverse here? Okay. The sine inverse of 0.8, 0.8 is 53.13. So theta is 53.13 degrees. So what will be the angle of the resultant? Remember, this is the direction of the resultant we are trying to find. So the direction is going to be, remember, that is northeast. So it's going to be north, 53.13 degrees east. This is the direction of the resultant. Now, what will be the direction of the equilibrant? Remember that the equilibrant and the resultant, they are what? Opposite in direction. So, the direction opposite to north is south. Direction opposite to 53.13 is same thing as 90 minus 53.13. So you are going to do 90 minus 53.13. That will be 36.87. So we are going to have 36.87 degrees. Opposite of east is going to be west. So this is going to be the direction, and this is going to be the magnitude. So take note of the equilibrant. Even though I think they asked us to calculate the equilibrant, so we are finding both the magnitude and the direction. I believe this is well understood. All right, so let's move to the next question, which should be the last question here. Says a boy travels 8 kilometers eastward to a point B and then 6 kilometers northward. He travels 8 kilometers eastward and then 6 kilometers northward to another point C. Determine the difference between the magnitude, only the magnitude of displacement of the boy and distance traveled by the boy. This is WAEC 2002, number 6. The solution. Draw your cardinal point to help you. 8 kilometers east, that is right. The other one is 6, so 8 should be longer. East. And then 6 kilometers north, so let me just give it to this one. You must not measure. You must not draw to scale. 6 kilometers north. Determine the difference between the magnitude of their displacement. Take note of this word. And the distance. Take note of this. What is the difference between distance and displacement? Distance is a scalar quantity. Distance does not have direction. It has only magnitude. But displacement is a vector quantity. So when combining distance, you don't consider direction at all. But when combining displacement, you have to consider direction. So to take note of this. All right? So you can see that these two directions now, how do we find the total distance? The total, that just like somebody moved 6 and moved 8 again. So the total the person moved, we don't care about the distance this person moved. So the total distance is going to be 6 plus 8, which will give us 8, 9, 10, 11, 12, 13, 14. 14 kilometers. This is the total distance moved. Now, what will be the total displacement? You don't just add. Before you can combine it, consider the direction. So you can see that the two directions, they are perpendicular to each other. So we need to complete our diagram and find the resultant. The resultant will be the diagonal. So if this is 8, here is 8, 6, here is 6, this will now be the resultant. The resultant is going to be the diagonal in the direction of what? Northeast. So cut it out to find the displacement. We are going to have this. Here will be R, this will be 6, and this will be 8. So R squared is going to be, to find this, you have to use Pythagoras theorem. So it's equal to 6 squared plus 8 squared. So R squared is equal to 36 plus 8 squared will give us 64. R squared is going to be 36 plus 64 is going to give us 100. So R is going to be square root of 100. Square root of 100 is going to be 10 kilometers. So this will be our displacement and this will be our distance. But the question they asked us to find displacement and distance, they said we should find the difference in mathematics, difference means subtraction, you subtract. So we have to minus the 2 to find the difference. So the difference is equal to 14 minus 10, which will give us 4 kilometers. I believe it is well understood. Bye. Okay, so the question we have here said that we should state 2 advantages of alcohol over mercury as a thermometric liquid. Number 1. 2, when the bulb of a thermometer is placed in a beaker of hot water, the level of the mercury first falls and then rises gradually. Explain this observation. Okay, so we are going to be answering the 2 questions. Solution. Advantages of alcohol over mercury as a thermometric substance. So number 1, so when you're asked to write this, you are going to write the advantages of alcohol, but you are going to be mentioning this over mercury. So it goes this way. Number 1, alcohol has a lower freezing point than mercury. The freezing point of alcohol is about minus 117 degrees Celsius. So compared to the mercury that is about minus 30 something. So when it comes to measurement of low temperature, we use alcohol. Number 2, you can say that alcohol is cheaper than mercury. Yes, because of this, alcohol is more available and also safer, because mercury is is poisonous. Okay? Mercury is poisonous. So alcohol is cheaper and also safer. Number 3, we can say that alcohol has a higher specific heat capacity. Sorry, than mercury. Okay, this should be a lower, because when selecting a good thermometric substance, we select the one with a lower specific heat capacity. Okay, its specific capacity has to be low. Okay, so and alcohol also expands. It expands faster than the mercury. That is why the alcohol will vaporize easily before mercury. So it expands faster than the mercury. So these are the advantages of alcohol over mercury. So we move to the second part, the B part of this question, that says, that the level of mercury will first fall and then rise when the bulb of the thermometer is placed in a beaker of hot water. Yes. The thermometer, for example, when the bulb is placed in a beaker of hot water, that first of all, This mercury will first of all fall before it will start rising. And the question is why? It falls because you know that this is hot water. And this is the glass now. Okay, and the tin bulb. The bulb, the glass itself, will absorb the heat first before the mercury inside. So when the body of the mercury, or the let me say the tube of the mercury, when it absorbs this heat, the glass there will do what? Will expand first. So when you have something of this size and you have a liquid at this level, when it opens up, when it expands, you notice that this height or this position will have to drop. So it will drop because of the first thing that will happen is the expansion of of the uh, the the glass or the tube of the mercury. So when it expands, it drops, then the heat will now get to the mercury. Because mercury is a better conductor than the glass, the mercury will now start rising. Remember that the first contact with the hot water is the glass. So the glass will expand, making the mercury to drop, and then the mercury absorbs the heat and will start rising. So that is why. So that dropping is because of the expansion. So what are you going to explain this observation? At first, okay, the bulb absorbs the heat from the hot water and expands and expands, making the mercury in the tube to drop or to fall. When the mercury absorbs the heat, it rises faster, or it rises. You can just stop there. So that is the observation. It drops because of the expansion of the bulb, and it expands because of the absorption of heat by the mercury. So it rises. All right. So we move to the next question. It says, state two physical properties used for measuring temperature. Okay? The physical properties that we'll watch in order to check increase or decrease in temperature, they are the physical properties used for the measurement of temperature are, number one, we have volume. Number two, we have pressure. Number three, we have resistance, electrical resistance. And four, we have electromotive force, EMF. So when we use different thermometric substances, they have properties that changes with temperature. For example, mercury, volume; alcohol, volume; gas, pressure; wire, resistance; thermocouple, electromotive force. So these are the properties. You can select two out of this. So we'll move to the next question. It says, what is a thermometric liquid? One. Two, state the reasons for the following design features of clinical thermometer. A, narrow bore and thin wall of the bulb. Okay? Okay, so first, let's see what is thermometric. Thermometric liquid. Every thermometer has thermometric liquid. So, thermometric liquid is a liquid contained in a thermometer whose properties, e.g. volume, changes with temperature. That substance in a thermometer whose property will always changes when temperature changes is called thermometric substance, and the liquid is called thermometric liquid. Now, state reasons for a clinical thermometer having a narrow bore. So the reason for it to have a narrow bore, the bore is the tiny tube inside. Why is that tube tiny? It's just to increase sensitivity. A little change. Remember that we use the clinical thermometer to measure temperature of the body. So little change in the temperature of the body, the narrow bore will help it to show, to be able to rise. So you know that it will increase capillarity. So that narrow bore will, the mercury can easily rise for a little change in temperature. So it's to increase sensitivity. Number two is the thin wall. So why the thin wall? Is just the thin wall of the bulb so that the wall can easily or rapidly absorb heat. So for faster rate of heat absorption, I can say that faster rate of heat absorption. Okay? So for it to be able to absorb heat, that is why the wall is always thin, and that heat can easily be transferred to the liquid inside. Because if the bulb is thick, if it is thick, the heat cannot be transferred so easily, to take time. So to absorb heat or conduct heat, just to increase conduction or the rate of conduction. So take note of that. All right. So we move to the next question. Next question says that we should name the material used to reset the steel index of 6 maximum and minimum thermometer. Okay, the material. So the 6 maximum and minimum thermometer is a type of thermometer used, for measuring the highest and the lowest temperature of a place. When you hear of highest temperature, lowest temperature, especially when it comes to weather, you watch in the television. We can use the 6 minimum and the maximum thermometer. So this thermometer uses mainly alcohol as its thermometric substance. Okay? But it also contains mercury. They add the mercury. The mercury will help us to get the maximum temperature or the current temperature of a place. So there is something we call the steel indices, a kind of metal made of steel that is added that will serve as a pointer. Something that when the mercury is rising, it will move with it and move up and show us the position, and it will remain there. So after taking the reading of a particular temperature, even when it is going down, this still index will remain there. So you need to reset. So in order to reset it, we use a small magnet. Magnet is used. When you place the magnet on the body of the tube, the steel will be attracted to it from the tube. So you can now drag it down to its initial position. So that is how to reset the steel in there. So the answer to this question is by the use of what? Magnets. Or you can say small pieces of magnets. All right. That will be the end to this. All right. The question we have here says, determine the magnitude of P in the diagram below. So look at the diagram. Okay, so questions like this, they are taking this is a WAEC question taken from the topic moment. All right, so and the principle of moment stated that the summation of all the moment of forces about a point on a body in equilibrium is constant. Okay, so which means that the summation of all the clockwise moments, is zero, please. So which means that the summation of the clockwise moment is equal to the summation of the anti-clockwise moment. That is, the resultant moment of a body in equilibrium is zero, which means that clockwise moment summation is equal to the summation of the anti-clockwise moment. All right, so the question we have here, I'm going to redraw this. So I'm going to redraw this. We have we have the meter rule, and we have the pivots. Look at the pivots here. And we have a load downward, 40 Newton, and the distance from the pivot to the load is 20 cm. So from here to here is 20 cm. Then we have another force, but this force is diagonal, okay? And the force is P. But this force made an angle 30 degrees to the horizontal instead of 90. I will tell you why the force should be 90. Okay, and the distance from this 40 Newton to the force is 30 cm, 30 centimeters. And they say we should find P. So what are we going to do? The first thing you will do here will be to straighten this force that is bent, that is diagonal. Straightening it means that I want to find I want to find the vertical component. That is what it means. It means that I want to find the vertical component. Because what is moment? So I need to straighten it. By finding a vertical force. What is moment? What is moment? Moment simply means the product of a force and its perpendicular distance. The distance has to be at 90 degrees with the force. But as you can see here, this force is bent. It's not perpendicular to this distance. So that is why I cannot use this force P to solve. I will need to use what? This force that will be a vertical component of P. And remember I said it, the vertical component of any vector R is R sine what? Theta, provided that theta is inclined to the horizontal. So in this case, our theta is 30 and our R is P. So what will be the vertical component here? The value here will now be P sine theta, which will be 30. So the force that I'm going to be using here is P sine 30 instead of what? P. Take note of that. All right, so we can now solve applying the principle of moment. Remember that the forces will act from their point to the pivot. So this force is acting here downward to the pivot. And this one up here is acting upward to the pivot. From this, we can find the clockwise and the anti-clockwise force, moment. So you can see this one is acting this way. This is how, if you watch the clock now, 12, 6, the clock moves this way, up, and this way down. This is how the clock moves. So any movement that is in this pattern is clockwise, but any movement that is opposite of it is anti-clockwise, while this is clockwise. Okay? This also is clockwise. Moving 6, 7, 8, 9, 10, 11, 12, or 1, 2, 3, 4, downward is clockwise. So you see, this 40 Newton is acting this way to the pivot, so the movement is clockwise. While this one is acting this way to the pivot, so the movement is anti-clockwise. All right, so remember that summation of clockwise moment is equal to summation of anti-clockwise moment. Now, moment is force times perpendicular distance. What is the force here? The force is 40, and the distance is what? 20. To the pivot, take note, to the pivot. So from here to the pivot is 20. So the clockwise is going to be 40 times 20. Somebody will ask, why is he using centimeters? You're meant to convert the centimeters to meter. Yes, but conversion in physics calculations, you convert only when the units are not rhyming. So you can see I have centimeters here, I have centimeters here. Don't bother. They will cancel out, okay? All right, so let's move on. Is equal to anti-clockwise moment, yes? What will be the force? The force will be this, okay, which is P sine 30 times the distance will be from this point to the pivot. So you see, it is not 30 because 30 is from this point to this 40 Newton force. So the distance will be from this point to the pivot, which is 30 plus 20. So that will give us what? 50 centimeters. Okay, so from here we can solve. 40 times 20 will give us 800 is equal to sine 30 is 0.5. So 0.5 P times 50. So I think that would be, do you know I can just reduce this way, and I will do 80 is equal to 0.5 times 5 will be 2.5 P. So divide both sides by 2.5. So my P becomes, let me use my calculator. Well, that would have been, okay. So 80 divided by 2.5 is going to give us 32. So that will be 32 Newton will be the value of P. I believe this is well understood. So we move to the next question. A uniform bar 15 meters long is balanced on a pivot placed at its midpoint. A boy of mass 55 kilograms sits on one of the arms of the bar at a point 5 meters away from the pivot. What mass can be placed 2 meters away from the other end to keep the bar horizontal? Solution. All right. A uniform bar is 15 meters long, so the full length is 15. Okay, we can just use this method. If it is 15, it means that the starting point is 0 and the ending is 15 meters. And it's balanced on a pivot. Pivot is the fulcrum, which is placed at the midpoint. What is the midpoint of 15? You should know that it's something as 15 divided by 2. So, midpoint, center of it, which should be 7.5. So from here to here is 7.5. From here to here is another 7.5. A boy of mass 55 kilograms sits on one arm of the bar at a point 5 meters away from the pivot. One boy is sitting on one arm, which is 5 meters away from pivot. So where do you want us to place the boy? We can place him here or here. 5 meters from pivot, which means we are like going to subtract 5 from this 7.5 so that we know the point where the boy will be. Just know that from here to here is going to be 5. I don't know if this is clear. So if you subtract 5 from here, I think this is going to be 2.5, right? Yes, 5 from here will give us 2.5. So the boy is going to be here. And the mass of the boy is 55 kilograms. And it's from 2.5 to 7 is going to give you 5. Or you do 7.5 minus 2.5. That will give you 5. What mass can be placed 2 meters away from the other end? The other end should now be this side. Because if I will place this one here, the other end will be from here. So the other end should be here. And they say 2 meters away from the other end. 2 meters from 15 should be how many? How many? You know, it's going to be 13. Because if you count 2 from 13 backward now, from the other end, so the other person is going to be here. This is going to be 13 because from 13 to 15 is 2. And they gave us, did they? Okay, they asked us to find the mass of the person. So the mass of this person, let me call it M. And that's all. So find the mass. So next, the forces will be acting from here to the pivot. This one is acting from here to the pivot. Which one is clockwise? The one that moves in the way of the clock. This is how the clock moves. So this should be the clockwise. This one moves against the clock. The clock doesn't move this way. So this is anti-clockwise moment. Moment is force times distance. So what should be the force here? Another person will now say, kilogram. Kilogram, is it force? Yes, it is not a force, but you know that they ask us to find mass here. So no need. Just like kilogram, they are rhyming together. Just continue. Okay, so this will be the force. So the summation of clockwise moment is equal to summation of anti-clockwise moment. So the clockwise moment is going to be this. The force is M times the distance is going to be from this point to the pivot. From 13 to 7.5 is going to be 13 minus 7.5. So when you do 13 minus 7.5, that will be what? I think that's going to be 5.5, right? Yes, 5.5. So 5.5 is equal to anti-clockwise moment. The anti-clockwise moment is this. What is the mass? The mass is 55 times the distance. The distance will be from here to here. From 2.5 to 7.5 is how many? It's going to give us 5, right? Yeah. So to make M subject of the formula, we just divide both sides by 5.5. Divide here by 5.5. I think if this will go here, it's going to give us 11. Yeah. Right? Am I sure? No, it's not 11. It's going to be 10. Yes. So when this cancel out, we are going to have M is equal to, this into this will give us 10 times 5. So M is going to be 50 kilogram or gram. kilogram. Sure. Simple. All right, so we move to the next question quickly. Masses M1. Oh, okay. Masses M and M2 at the 20 cm and 65 cm marks, respectively, of a uniform meter rule freely suspended at its center of gravity. Okay? Underline this first. If the meter rule balances horizontally, determine the ratio M2 is to M1. M1 again. So which means the first one is M1. So this is going to be M1. M1. So solution. Masses M1 and M2 at 20 cm and 65 cm marks of a uniform meter rule. In fact, if the length of the uniform meter rule was not given to you, just know that it's going to be 100. The standard meter rule in the lab is 100 centimeters, okay? Unless we have another one that is longer, which the length will be given to you. So I'll have to draw the meter rule, call this 0, and here is going to be 100. They say that masses, M1 and M2, M1 is at 20, M2 at 65. So let this be my 20 now. Call it M1. And let the 65 is going to be more than the center. So let this be the center. And let here be the 65. Okay, and this is going to be my M2. Suspended at its center of gravity. When they say suspended, it's the same as saying pivoted or pivoted, okay? So the pivot is here at midpoint. Midpoint of 100 is like half of 100, which is 50. If the meter rule balances horizontally, determine M2 is to M1. If it balances horizontally, okay, find M2 is to M1. So we solve quickly. We are going to use our principle of moment. Summation of clockwise moment is equal to summation of anti-clockwise moment. Remember, this one is acting from here to the pivot, and this is acting from here to the pivot. So, in the way of the clock, against the clock. So, clockwise, what is the force? M2. What is the distance from this point to the pivot? From 65 to 15, which is going to be, to 50, which is going to be 15, is equal to the force here, M1, times the distance is from 20 to 50, which is going to be 30. Same thing as 15 minus 20, which is 30. Okay? Now, calm down. Some students, I will tell you the mistake that students used to make when they ask you this kind of question. Some people will just say, because they said M2 is to M1, they will say 15 is to 30. Now lie you. The answer will fail you. Okay? So when they say ratio M2 to M1, it means that they're asking you to find M2 over M1. Which one is down? Which one is the denominator? M1. So when they say find the ratio of M2 is to M1, and you get to this point, please just divide both sides by the one that is down, so which is M1. So I will just divide here by M1, divide here by M1, and make M2 is to M1 subject to the formula. So when I cancel out here, what's remaining? I will have M2 over M1 times 15 is equal, I can just decide to divide it. It's still the same thing as dividing everything by M1. Yes. So 15 is equal to 30. So what next? Make this subject to the formula. So which means I will divide both sides by what? 15. Divide by 15. So cancel out. I'm going to have it that M2 over M1 is equal to 30 over 15, which will give us 15 into 30 will give us 2 over 1. So what will be my answer? The answer is going to be 2:1. Yes. So that is it. Take note. I hope it is well understood. So we move to the last question here. The question says, which of the following statements describes a body in a stable equilibrium correctly? Okay. We have three types of stability or three types of equilibrium. Three types of equilibrium. Number one, let me just talk about that before we can now answer this question. Number one, we have stable equilibrium. Stable equilibrium. Number two, we have unstable equilibrium. And number three, we have neutral equilibrium. Stable, unstable, and neutral equilibrium. I'm going to give you the examples of these. Okay, now I'm going to use a cone to explain this. Stable equilibrium is that type of equilibrium when a body regains its shape, or a body will retain its position when displaced. As I am standing here, you push me, I will not leave my position, but I will shake, but I will remain where I am. So this type of you shake, you return, you did not leave your position when displaced. So this is stable equilibrium. So when you have a cone standing on its base, this is stable equilibrium. Unstable. Unstable is when you push me and I fall, I lie flat. A body is standing this way, you push it, it falls this way. When the body cannot even stand, when the body is placed, it falls. That body is unstable. That is, the equilibrium is unstable. Okay, just like this pen stand. If I will leave this now, it's going to fall. If I leave it, it's going to fall. So because this is unstable. So if I will use, when it is standing on its vertex, so it is unstable. Neutral. What's the difference between neutral and stable? Now listen, neutral equilibrium is when a body will change its position and regain its equilibrium at another position, not at the initial position. For example, this object is lying this way, you tap it, it rolls and moves to another position before it balances again. A body is balancing, but when you displace it, it leaves its position to balance elsewhere. That type of equilibrium is neutral equilibrium. So when this cone is lying this way, sorry. Oh. Please forgive me. I don't even know what I'm drawing here. So when the cone is lying this way, see, so it can only roll and balance. It will not, but the other one, when you tap it, it can only shift, but will not leave the position. Take note of this. So walking on a tightrope, will you balance? No. No. So this is unstable. A ball on a smooth horizontal table. A smooth horizontal table. Tap it, it will roll and then stop. That is neutral. So this is neutral. No. A ball resting on an inverted hemispherical bowl. You have a bowl and a ball is here. It's unstable. Biko is unstable. D, a ball in the middle of hemispherical bowl is balanced. So our answer is going to be the option D. See you guys. Hello. The question here says a piece of copper block of mass 24 gram at 230 degrees Celsius is placed in a copper calorimeter of mass 60 gram containing 54 gram of water at 31 degrees Celsius. Assuming heat losses are negligible, calculate the final steady temperature of the mixture. We are given the specific heat capacity of water as 4,200 and the specific heat capacity of copper as 400 joule per kilogram per Kelvin. Okay, so quickly to solve this question, this particular question here is based on the topic measurement of heat energy. So here we have the heat capacity and the specific heat capacity. Okay? All right, so before you solve questions on this particular topic, I want you to write this first. Remember that heat gained is equal to heat lost. So let me use H for heat. So heat gained is equal to heat lost. In this case, we are looking at heat that can cause, we have different properties now, different effects of heat. Change in temperature, change in state, expansion, increase in or change in pressure, thermionic emission, and so on. Even the physical and the chemical properties. These are the effects of heat. But here we are looking at the two major effects of heat, change in temperature and change in state. Heat capacity or specific heat capacity, the two has to do with the heat that will cause a change in temperature. And the formula for heat, quantity of heat that will change temperature is given by H is equal to MC times change in temperature. Where this small letter C here, or let me use CP here, represents the specific heat capacity. The amount of heat required to change the temperature of a unit mass of a substance by at least 1 degree Celsius. Specific heat capacity. Okay? This is the heat that will cause a change in temperature. And this will be the heat that will cause a change in state, where L is specific latent heat. All right. Now, when you must have written heat loss is equal to heat gain, identify which body is losing heat here, which body is gaining heat. Hot body is losing heat. When you mix hot and cold, you know that the result is going to be warm. Hot will lose heat. Cold will gain heat. Both will achieve equilibrium or warm. So copper is 24. At about this high temperature, 230, placed in a copper calorimeter. When you place something, okay, the copper calorimeter 60 gram, the copper calorimeter is containing water, 54 gram, 54 gram at temperature of 31. So you see that this temperature is small, while this temperature is big. So this is hot, this is cold. So which means that the copper block is losing heat. And what is gaining heat? Water. But not just water, because inside of this water, you have a container, calorimeter, containing water. So if the temperature of this water is 31 degrees Celsius, it means that the temperature of this container is also going to be 31 degrees Celsius. If this water is hot, the container will be hot. If this water is cold, the container as well should be cold. Okay, so take note. So heat is now gained by what and what? One, the water. Two, the container. All right, so can I say heat lost now? Okay, heat gained should be heat gained by water plus heat gained by container is copper container or calorimeter. I think they called it calorimeter, so let me call it calorimeter. So this will be the total heat gained is equal to heat lost is heat lost by copper block. So heat lost by copper block. Now we have identified the ones losing and the one gaining. The next question is heat gained. What did he do to the body? Heat lost. What did he do to the body? Now let's look at what happened there. After mixing, assuming no heat losses, calculate the final steady temperature. Final steady temperature is just like that warm temperature. The hot was mixed with the cold. Everything became warm after some time. So which means water was cold initially, but finally water became what? Warm. What happened to water? Change in temperature. It did not change in state. Only two things can happen as it regards to this topic. It is either the temperature is changing or the temperature or the state is changing. If the temperature is changing, this will be the formula of heat. If the state is changing, this will be the formula of heat. So, water change in its temperature. Calorimeter also change in its temperature because if this water is hot or warm, calorimeter also will be warm. So, initially water was cold, finally warm. Calorimeter cold, finally warm. Copper initially was hot, but finally warm. So you can now see that what happened to the three is changing temperature. So which formula am I going to use? This. So for water, the formula will be mass of water times specific heat capacity of water times change in temperature of water plus mass of calorimeter times specific heat capacity of calorimeter times change in temperature of calorimeter. This one also changed in temperature. So the formula will be mass of copper times specific heat capacity of copper times change in temperature of copper. Now we are getting to somewhere. So can we start fixing? There's something you need to know again. This calorimeter, go to the calorimeter. You notice that they called it copper calorimeter. So which means that the calorimeter was made of copper. So since it's made of copper, it will have the same specific heat capacity with what? Copper block or whatever. Whether copper bucket, copper pen, they will have the same specific heat capacity. Okay, so now can we fix the values we have here? So from the question, what is the mass of water? Containing 54 grams of water. Can you see? Okay, but this is gram. This is gram. I think they are rhyming. So because they are rhyming, let me just leave it there. If not, I would have said we are going to convert from gram to kilogram, but they are going to cancel us somewhere, so no need for that. So what is the mass of water? Mass of water, they said, is placed in a copper calorimeter of mass 60 grams. So this one is the mass of copper calorimeter, containing 54 grams of water. So here will be 54 times specific heat capacity of water was given. Look at it here as 4,200 times change in temperature of water. How do we find the change in temperature of water? Initially, water was cold. Finally, water became warm. Which one is going to be bigger? Warm is bigger than what? Cold. So the change in temperature is going to be warm minus what? Cold. But remember, it is this warm temperature that they asked us to find. Final steady temperature. So, what am I going to write? Change in temperature of water. Let me call this final steady temperature theta. Okay? theta minus temperature of water initially. What's the temperature of water? That cold temperature is 31. So 31. Plus, I think I'm done with water. So we'll now move to the next one. Mass of calorimeter. Mass of calorimeter is 60. 60 times, what am I writing here? CP. Specific heat capacity of calorimeter. Specific heat capacity of calorimeter is still going to be specific capacity of copper given here, because look at it. Specific heat capacity of copper is 400 because the calorimeter is made of copper. So it's going to be 400 times change in temperature of calorimeter. In fact, the calorimeter and the water will have the same change in temperature because the calorimeter will just they follow the water. You know, if the water is hot, calorimeter is hot. If the water is cold, calorimeter is cold. If the water is warm, calorimeter is warm. So change in temperature for calorimeter is still theta minus 31 is equal to, now heat loss, mass of copper. The mass, piece of copper block now is 24. Look at it. So 24 times specific capacity of copper, the same thing again, 400 times change in temperature of copper. Initially, that one is hot now. And finally, warm. Hot and warm, which one is bigger? Hot. So it's going to be hot minus warm, which will be 230 minus theta. So with this, we can finish up. Put our bracket now. In the bracket, we are going to have our calculator. Let me just, I can factorize this and this, and I will do 54 times 4,200. Just work it out yourself. You're going to have 226,800 226,800 bracket theta minus 31 plus 60 times 400. We'll have 24,000 bracket theta minus 31 is equal to, open the bracket for the other one, 24 times 400. We'll have 9,600. 230 minus theta. Because I'm going to do this my way. Do it your way. This is no longer physics. This is mathematics we are trying to do. So, to make this subject, I think I can factorize this plus this. I will have 226,800. I'm doing this just to economize space, plus 24,000. I will have 250,800 bracket theta minus 31, because I have theta minus 31 here, I have theta minus 31 here, bring it out, so you now have this plus this remaining, is equal to 9600, 230 minus theta. You know the reason why I'm doing this? I just want to see if I can reduce some things. So I can just decide to divide this. So if I will do this divided by 96, I will just have 26.13 bracket theta minus 31 is equal to 230 minus theta. How I can decide to open my bracket. So times 31. So if I open the bracket, I'm going to have 26.13 theta minus 809.88 is equal to 230 minus theta. Collect like terms now. Collect like terms for your theta. Collect like terms. So we are going to have minus theta, we cross to the other side. So we have 26.13 theta plus theta is equal to 230 plus 809.88. So 26.13 theta plus theta will give us 27.13 theta. If you add it up. So the other one is now going to be 809 plus what? 230. Second time now, 1039. 1039. So to find theta, we divide both sides by 27.13. Divide by 27.13. Cancel out. Theta is going to be, so divided by 27.13. It's going to give us 38.33. So our final answer is going to be 38.33 degrees Celsius. Oh. So our answer is going to be 38.33 degrees Celsius. All right. So that is it. So you can see at 230, very hot, 31. When you mix, you are going to achieve 38 as your equilibrium temperature. All right. The next question. A 40-volt electric heater is used to supply a current of 12 amperes for 1,400 seconds to a body of mass 1.5 kilogram at the melting point of the body. The body melts and its temperature rises through 60 degrees Celsius in an extra 72 seconds. Calculate the specific heat capacity of the body. So solution, quickly, this is WAEC. Question, still based on specific heat capacity, electrical method for the measurement or determination of specific heat capacity. Okay, so remember, heat gained equal to heat lost. Identify which one is gaining, which one is losing. Which one is gaining here? The one that is cold, the one that is receiving heat. So, a body. Electric heater is used to supply current for blah, blah, blah to a body at its melting point. So this is the body receiving heat. So which means heat gained by the body is equal to heat loss. Which one is losing heat? Is the electrical heater. And the heater is losing the heat electrically. So if we are talking about the electrical energy used in form of heat, we have these formulas. The heat is equal to IVT equal to I square RT equal to V square over RT times T and is equal to power times time. Take note of this. These are the formulas that we can use to represent the amount of heat that is supplied electrically. Okay? So heat is equal to heat by the heater. Now, what did the heat do? This question says we should find the specific heat capacity of this body. Now, listen. They said that heat was supplied to this body at the melting point of the body. So the body will melt. One, melting, which is change in state. Then they now said that after melting, the body melts and its temperature rises. So two things happen to this body. One is melting and two is what? Increase in temperature. So the heat gained by the body will cause it to melt, which is ML, latent, specific latent heat of fusion. Plus, it will also change in temperature. Heat that changes temperature is what? MCP, change in temperature. But listen, this question says that we should calculate the specific heat capacity of the body. Where is the specific heat capacity involved? Is it not here? Yes. So heat was supplied because they told us that it happened in extra 72 seconds. The temperature increased, heated through, please, rises through. Take note of this. Rises through means change in temperature. The temperature increased by 60. So the change in temperature was given as 60 degrees Celsius. And they said that this happened at a time of what? 72 seconds. You don't need to start adding this time and this time, because this time is the time used in causing this to do what? To melt. But extra 72 seconds was used, to change the temperature. So the answer we should find specific heat capacity. So which formula am I going to use here? I'm going to use just this alone. I'm not going to combine the two. Okay? So the total heat supplied is going to be heat gain. So the heat gain is going to be MCP, change in temperature. And heat loss is going to be heat loss, yes. Which one is heat loss? Heat loss is going to be heat lost by the heater and is electrical now. So since I have I, current is I, voltage or potential difference is V, T is time, R is resistance, okay, and P is power. So here we have V and I. So which formula do you think you can use here? You look very well. You notice that the formula to use is this, where T is time. So is equal to IVT. So when we substitute, our mass is given as 1.5 kilogram. Specific capacity, specific heat capacity of the body, was it given? That is what we are looking for. Times CP times change in temperature. It was given direct as 60. Okay? Is equal to I is current 12 times voltage is 40 times time. The time used in causing change in temperature is extra 72 seconds. Take note of that. So that is why I'll write times 72. Okay? If you are going to add this plus this, you know that specific latent heat of fusion was not given. Okay, so if you are going to add this and this, for you to use 1400 and this as your total time, it means that you are going to use everything here. But remember, in this question, ML was not given. So it's better that you just mind your business and use the heat. This one that was given to you, just mind your business, okay? So when we do this, we are going to have we are going to have 1.5 times 60. That will be 90 CP is equal to 12 times 40 times 72. That will be 34560. That is 34,560. So we divide both sides by 90. Divide by 90. Cancel out. Our CP is now going to be 384 joule per kilogram per Kelvin. All right. The next question says, explain the statement, the specific heat capacity of copper is 400 joule per kilogram per Kelvin. I think I've said this before. A way of asking you to define specific heat capacity. So if you remember that specific capacity is equal to amount of heat required to change the temperature of a unit mass of a substance. So when they now say that this is equal to 400, what does it mean? So it means It means that 400 joules of heat energy is required to change the temperature. They say basic capacity of copper. So to change the temperature of 1 kilogram of copper by 1 Kelvin. So that is what it means. It means that 400 joule, you know that this is heat required to change the temperature of that substance by at least 1 degree Celsius or 1 Kelvin. And this is the mass, change the temperature of a unit mass of this substance. So if this is 400, it means that it will require 400 joules of heat. Okay? 400 joules of heat to change the temperature of 1 kilogram of that substance, which is copper, by 1 Kelvin. I hope it is well understood. Well done. So the question we have here is that we should state two each. A, laws of solid friction. B, advantages of friction. C, methods of reducing friction. So to answer this quickly, solution. Let's start with laws of solid friction. Why solid friction? Does it mean we have liquid friction or gaseous friction? Yes, we have. Okay? Solid friction or friction, simply when they say friction, they are referring to force that opposes the relative movement or relative motion of a solid over a surface. When solid is moving over a surface, the force that opposes the motion of the solid over a surface is called friction. If the same thing will happen in liquid or gas, we don't use the word friction for it again. We call it viscosity. That is why you see solid friction here. So, laws of solid friction, we have so many of them. So let's start with laws of solid friction. Number one, you can say that friction is directly proportional to normal reaction. Two, friction depends on nature of surfaces in contact. Number three, friction is independent or does not depend on surface area. We have others like friction opposes motion. Friction is independent on relative speed. Okay? So take note, you can add all of these to the laws of friction. B says that we should state the advantages, two advantages of friction. Two advantages of friction. Number one, friction helps in grinding. Yes, with the aid of friction, we can grind. It helps in sharpening. Grip, gripping of an object. Without friction, I cannot hold this. I can't be writing with this. So with friction, with the aid of friction, we can grip. Friction helps even in the production of static electricity. Okay? Because, please, I don't know why I can decide to ask you to state the applications of friction. So some of these applications indirectly, they also mean advantages of friction. So I can also add this as an advantage because it can be used or applied in in the production of some things that are very useful to the society. So friction also can be used in the or helps in the production of static electricity. Yes, I remember one of the ways of producing static electricity, or we have two methods of producing static electricity. We have the friction method, yes, and we have the induction method, and other methods though. We have other methods. All right, so take note, advantages of friction. So next, they can also ask you disadvantages of friction. It causes wear and tears of machines. You know, friction can lead to the generation of heat in automobiles engine. Because of friction, heat can be generated, and this is very bad for the engine. Friction slows down motion. So because of that, it reduces what? Efficiency. So these are the disadvantages. It causes wear and tear when they are rubbing against each other. It causes the generation of heat, especially in the automobile engines. Friction can also bring about the slow, that is, it can slow down the speed or slow operation of machines, which will reduce the efficiency of the machine. So take note. Now, the next question they asked us here, they say we should write two methods of reducing friction. Number one is number one is by lubrication. Lubrication, that is using lubricants, to reduce or to smoothen the surface. So using by lubrication. Number two can be by smoothing or the use of powders. When you spread powders on some surfaces, you can make it smoother. So you can write by the use of powders. Smoothing, using the sandpapers to smoothen, or the powders on the sandpapers. I believe you know what I'm talking about. You can also use streamlining, designing the object in such a way that when it moves, but this one, the streamlining method occurs especially, no, because they asked us about solid friction, let me just remove this. I will remove this. So let's use lubrication and smoothing by the use of powders or the sandpapers. Okay, streamlining has to do with when a body, a solid, is moving through a fluid, Okay. So that is it for friction. So we move to the next question. It says a wooden block of mass 1.6 kilogram rests on a rough horizontal surface. If the limiting frictional force between the block and the surface is 8 Newton, calculate the coefficient of the friction if acceleration due to gravity is 10. Okay? So solution, a wooden block rests on a rough horizontal surface. So let this be the rough horizontal surface. And this will be the block of mass on it. And the mass is 1.6 kilogram. If the limiting frictional force, we have two types of friction. We have the static or the limiting frictional force, and we have the dynamic or the kinetic or kinematic friction. So the kinetic, the friction that happens when a body is in motion. So for that body to maintain uniform speed, the body will have to overcome kinetic or dynamic friction. Static friction, friction that happens when a body is not moving, when a body is at rest. So this is the friction that must be overcome for a body at rest to start moving. Okay? So at rest, it means that the body is balanced. The force that is causing it to move is balanced by the friction. So no acceleration on the body. Okay? So we are given the frictional force acting on this body. Let me call the frictional force Fr as 8 Newton. And we're asked to find the coefficient of friction. Okay? So what are we going to do? Remember that frictional force F is equal to mu times R, where mu is the coefficient of friction and R is the normal reaction. R is normal reaction. And this normal reaction, what is normal reaction? Normal in mathematics and physics is all about anything that is 90 degrees or at right angles to a surface. This particular hand now is normal to the other one because it is 90 degrees. Now, normal reaction is the force that is trying to balance weight. If I will leave my hand now, it falls. But if I will attach this second hand, I am trying to balance it. I'm trying to hold the weight. So, and before this weight, I can hold the weight. If not, the two will go down. This force produced by this hand must be equal to the weight going down. So the force that is balancing the weight is called the reaction, and it is always acting in opposite direction to the weight. So if weight is going downward, reaction is going upward. That is why as I'm standing now, you are standing, the reaction from the ground is balancing you. If not, you and the ground will sink. Okay? So that reaction should be equal to weight on a horizontal plane, should be equal to weight on a horizontal plane. So which is equal to M times what? Times G. Weight is equal to mg. So substitute here, we are going to have it that frictional force Fr is equal to mu times R, which is mg. So if we solve quickly, substitute, we are given the frictional force as 8. So here should be 8. Mu is what they say we should find, coefficient of friction. So mu times m is 1.6 times 10, which is g. So 8 is equal to 1.6 times 10 will give us 16 mu. Divide both sides by 16, divide by 16, cancel out. Mu is equal to 0.5. Coefficient of friction does not have any unit. So this is just the answer. So which will make this option the correct answer. To the next question. So the question here says, a block of wood of mass 5 kilogram is pulled on a platform by a force, look at the force pulling it, 40 Newton as illustrated here. If the frictional force F experienced by the block is 12 Newton, calculate the magnitude of the acceleration of the block. This question is WAEC question based on friction. This is a block. You are pulling it with a force. So you expect it to move in the direction of the force. But as this body is moving forward, friction is the force that opposes motion. So you expect friction to act opposite. So the friction is opposing it. So they gave us the friction as 12. Yes? Yes. So which means the force here is 12 Newton. The frictional force opposing this force. But they said, calculate acceleration. Acceleration means that this body is still moving. The friction did not stop the body from moving, unlike the other one we solved. Okay? Acceleration means that the friction could not stop. Imagine pulling with 40, pulling with 12. Is it going to move? Yes, it will move. It will move in the direction of 40 because 40 is bigger than 12. Okay? So, but which force do you think will make it to move? Is it 40 now? No. It's going to be, you are going to remove this 12 from the 40 to get the remaining force that is causing it to move. I believe it is clear now. All right. So that shows that the body is still accelerating. Accelerating in which direction? In the direction of P. So what are we going to do? This will be the horizontal, and we have the force pulling it this way, friction pulling it this way. This is 12 Newton, and this is 40 Newton. Okay? So we expect the force, final force to act here to be 40 minus 12, which should be 28, right? Yes. 28 Newton remaining. So they say we should find the acceleration. Find the acceleration. So what will happen? Remember that the force, subtract the two forces, you now get F is equal to ma, where this F is the resultant force acting on this body. And that force is equal to mass times acceleration. So F here becomes 40 minus 12. That will be the resultant force is equal to mass times acceleration. 40 minus 12, that will give us 28 is equal to, our mass was given as 5 times acceleration. So to find acceleration, we divide both sides by 5. Cancel out. A becomes 25 over 5. Sorry, 28 over 5. And when we do that, 28 over 5 with our calculator, we are going to have it that 28 divided by 5 will give us 5.6. So this is going to give us 5.6 meters per second square. Simple. All right. So we move to the next question. Okay, this is supposed to be our last question on this. Well done. Hello. The question we have on the board says the force F acting on the wings of an aircraft moving through air of velocity v and density rho is given by the equation F is equal to, as you can see here, K v raised to power x rho raised to power y a raised to power z, where K is a dimensionless constant and A is the surface area of the wings of the aircraft. Use the dimensional analysis to determine the value of x, y, and z. All right, so this is a WAEC question based on dimensional analysis or dimensions. So before we solve this question, I will need to give you the dimensions of basic quantities. The basic quantities or the fundamental quantities will have the following dimension. One is the mass. Mass is a basic quantity, length, and other quantities associated to length, time, temperature, current, and so on. These are the basic fundamental quantities or the basic quantities. The dimension of mass, we use capital letter M. Length, we use capital letter L. Time, we use capital letter T. Temperature, we use theta. And current, we use capital letter I. Dimensioning or dimension is all about using only the fundamental quantities to represent the derived quantities. Okay? So here we are given the force F, which is a derived quantity. And the F is a function. F is equal to K V raised to power X rho raised to power Y and A raised to power Z. K is a dimensionless constant. So for something to be dimensionless, it means that it has no dimension. It has no unit. So which means we are not going to count K as part of what we are doing. Okay? So, and F is force, V is velocity, rho is density, A is area. So before you can do this, you must know the formulas of the derived quantities given. First, we have it that force is equal to mass times acceleration. And the dimension of force is given by, since mass is big M, and acceleration is in meters per second square. Meter represent length, second square will represent distance, time square. Okay, so force will be represented by MLT minus 2. This is the dimension of force. Velocity, V, the formula is displacement all over time. The dimension, displacement is distance or length, which is L, and time is T. So velocity is going to be LT minus 1. Density. The formula for density is mass all over volume. Mass is M divided by volume is L cubed, that is length times breadth times height, which is same as length times length, which will give us L cubed. So when you bring it up, it's going to be L raised to power minus 3. This is the dimension of density. Remaining the area. Area has the dimension of L square, that is length times breadth. Length is length, breadth is also length, so this will give us L square. Okay, so we're going to substitute the dimensions of all of these 1, 2, 3, 4. Keeping these powers. So what are we going to have here? For force, we are going to have m L T raised to the power minus 2 is equal to, first, eliminate k since it is dimensionless. So we continue with v. Our v is LT minus 1, but the power is raised to x. So I'll write raised to power x. Normally, we are meant to use this type of bracket. Next is rho density raised to power y. I'm going to write m L raised to power minus 3, everything raised to power y. Next is area raised to power z, which will give us L square raised to power z. So the next will be to open up the powers according to indices. When you have A raised to power n, when you have A times B, all raised to power n is going to be A raised to power n times B raised to power n. So having this, we are going to arrive at m L T raised to power minus 2 is equal to, this would be L raised to power x times T raised to power minus x. Minus 1 times x will give us minus x. Let me keep this together. Here will give us m raised to power y times L raised to power minus 3y. Keep this. The last will be L raised to power 2z. What next? We kind of rearrange to place the like terms together. So I'm going to collect all the m's together, all the l's together, and all the t's together. So we'll have m L T minus 2 is equal to, the m we have here is just only 1. So this particular one here, I'll bring it here. That will give me m raised to power y. Keep it aside. The l's will have this, and we'll have this, and we'll have this. Bring the 3 together. So we are going to have L raised to power x times L raised to power minus 3y times L raised to power 2z. That is for L. Next is T. How many T's do we have here? There's only one. So this will be the T. So we'll write times T raised to power minus x. What next? Applying the law of indices. When you have powers of the same base, you have to add up the powers. So for example, a raised to power m times a raised to power minus b will give us, since the base they are the same, this will be a raised to power m plus minus b, which will be same as m minus b. Add up the powers when you are multiplying. So here we are going to have m L T raised to power minus 2 is equal to m raised to power y, then L raised to power x plus minus 3y plus 2z. That would be x minus 3y, then plus 2z. Then times, the next is going to be t raised to power minus x. Now that we have gotten to this stage, next will be to compare what we have on the right-hand side to what we have on the left-hand side. Okay, so as you can see, we have M on the left, we have M on the right, L on the left, L right, T left, T right. So what is the power of M here? Is 1, since nothing is written. Power of L is also 1, since nothing is written. Power of T already is -2. So we are going to compare. So which means M raised to power 1 should be equal to M raised to power Y. And L raised to power 1, that is the left-hand side, is equal to L raised to power X minus 3Y plus 2Z. And lastly, T raised to power -2 is equal to T raised to power minus X. Okay, so looking at this, you will see that it's going to be easier for us to find Y, because Y already is there. M will cancel M. So this shows that Y is equal to 1. This one is still long, but let me write it out. So can we now say also that L, we cancel out L here. We have 1 is equal to X minus 3Y plus 2Z. Keep it aside. For the third one, if we cancel out for the T, we have -2 is equal to minus X. -2 is equal to minus X. With this, we can say that X is equal to 2. So since X is equal to 2, Y is equal to 1, we can now find Z by substituting X and Y into this particular equation. So this equation becomes 1 is equal to X is 2 minus 3Y is 3 times 1 plus 2Z unknown. So 1 is equal to 2 minus 3 times 1 is 3 plus Z. 2 minus 3 will give us -1. So 1 is equal to -1 plus Z. Make Z subject of the formula. If you make Z subject of the formula, you notice that Z here is going to be 1 plus 1, which is going to give us 2. So from this, we have it that X is equal to 2, Y is equal to 1, and Z is equal to 2. And that answers the question. I hope it is clear. All right. So we'll move to the next question. The next question says that the velocity of a wave in a stretched string depends on the tension T in the spring and mass per unit length mu. Okay, we call this mu of the spring. Obtain an expression for V in terms of T and mu using the method of dimension. So you see that dimension has so many applications. Dimension can be used, to make formulas, knowing the quantities or the parameters involved. Dimension can help you to make or to formulate. All right. So this is a question on dimensioning or dimension analysis, WAEC 2020. Okay. So solution. So next, we write out the parameters involved. They say that the velocity here depends on tension depends on mass per unit length, which is mu. So one, tension, which is a force. Tension is a force of pull. So tension, which is a force, is T. Mass per unit, P-E-R in physics means all over. So mass per unit length is something as mass over length was given as what? Mu. So what next? And they say that this is a function of velocity, or velocity is a function of these two. So what am I going to do? I'll write, let velocity be v is a function of these two parameters, which is t and mu. Okay, now I'm going to rearrange this. I'll say, let the power of t be x, and let the power of mu be y. Okay, so when I do this, I will have to fix the parameters. I will fix their dimensions. So what is the dimension of velocity? Velocity is displacement all over time. So what the dimension of velocity is going to be Lt raised to power minus 1 is equal to dimension of tension. Tension is same as force. So the dimension of tension is MLT minus 2. But since T is raised to power X, so this is going to be raised to power X. Okay, next is mu. Mu represents mass per unit length. So what will be the dimension of mu? Dimension of mu is going to be mass, which is m, over length, which is L minus 1. Raised to power y, raised to power y. So what next? You apply the law of indices, opening the bracket, we are going to have LT minus 1 is same as m raised to power x times L raised to power x times t raised to power minus 2x. Remember, minus 2x, x, and x. Yes, combined with this will be m raised to power y and L raised to power minus y. M raised to power y, L raised to power minus y is equal to LT raised to power minus 1. So next will be to rearrange, bringing the like terms together. So we're going to have it that L raised to power T minus 1 is equal to, how many M's do I have here? M. So we're going to have M raised to power X and M raised to power Y. Okay, next is L. Yes, we have L here, we have L here. So bring the two together. We are going to have L raised to power X and L raised to power minus Y. What next? T. So we have only one, so which is T raised to power minus 2x. What next? We compare. No. Before we compare, we need to resolve these two and these two. All right, so we are going to have LT minus 1 is M, according to indices. You add the powers, so this will be X plus Y. And here we have L X minus Y and T raised to power minus 2x. So what next? We compare. Now I want you to look at this. You notice something. We don't have M on the right-hand side. We only have L and T, but we have M on the right-hand side. So what are we going to do? If we don't have M here, it means that M is raised to power 0. Because any number raised to power 0 is going to give you 1. So that is why I'll have to include M so that I can compare. So M raised to power 0, L raised to power 1, and T raised to power minus 1 is equal to M raised to power X plus Y, L raised to power X minus Y, and T raised to power minus 2X. Compare. So can we say M raised to power 0? Or instead of doing this, we can just go straight to the point. Instead of doing this, we can just say, we have it that 0 is equal to X plus Y. So can we say X plus Y is equal to 0? I can call this equation 1, the first one from M. If we compare L, we have X minus Y is equal to 1. If we compare T, we have minus 2X is equal to minus 1. I think looking at 1, 2, 3, the one that will give us an answer straight is equation 3. So can we say that, can cancel out this so that X is equal to 1 over 2. So since X is 1 over 2, can I substitute X in either equation 1 or equation 2 so that I can find Y? So if I will do that, we're going to have it that X, which is 1 over 2, plus Y, which is unknown, is equal to 0 using equation 1. So if I make Y subject to the formula, Y is going to be minus 1 over 2. Now with this, I've gotten X and I've gotten Y. X is 1 over 2, Y is minus 1 over 2. So with this now, can we go back to the start? V is equal to T raised to power X mu raised to power Y. The question did not ask us to find X and Y. The question says that we should derive or make a formula that is connecting 1, 2, and 3. So what are we going to do? Bring the formula back. V is equal to T raised to power X mu raised to power Y. Then substitute X and Y. What are we going to have? We have it that V is equal to T raised to power X. Our X is half. So T raised to power half times mu raised to power Y, and our Y is minus half raised to power minus half. Remember, according to indices, any number that is raised to power that will have a negative power will go down as a denominator. If, for example, we have a raised to power minus n, is going to be 1 over a raised to power n. So it will move down with its power. So what are we going to have here? V is equal to T raised to power half all over mu raised to power half. Next, according to indices, any number or any value that is raised to power half simply means the square root of it. For example, B raised to power half is same thing as square root of B. So T raised to power half here, we are going to have V is equal to T square root of T divided by square root of mu. So with this, we are going to have it that V is equal to square root. Since I have square root and square root, combine it together, we are going to have T over mu. I can now bring in my K, the forgotten K that doesn't have a dimension. So what will now be the formula? Remember that we have K attached to the, oh, sorry, not this. Okay, so this is going to be our answer. All right. So I hope this is clear. So can we move to the next question? It's kind of long, but it's easy. It's easy. So quickly, state the SI base unit of the following physical quantities. This is about units, SI units, base units of these quantities. A is stress, B, force constant, C, Planck's constant. This is WAEC 2024. Okay, solution. Solution. So let's start with stress. First, you need to know the formula before you can state the unit or before you can write the unit. The formula for stress is force per unit area. Stress and pressure, they have the same formula and units and dimension. So force over area. Remember, the question did not just ask us to state the SI unit, but it said SI base unit. So which means that all of the units will be in fundamental, okay? They will be base. So unit of force is Newton, yes. And unit of area is meter square. So I would have written Newton per meter square, but no, you don't stop here. You need to break down the Newton because Newton is not in its base form. So Newton is same thing as, you can remember that force is mass times acceleration. So Newton will now be kilogram, and as that is mass. Acceleration will be meters per second square, now divided by meter square. So this will give us kilogram meters over second square times 1 over meter square, which meter will cancel out 1 meter. So the unit is going to be kilogram per meter. This meter will come up and now have a negative power. Then per second square. This is going to be your answer. Please note this. That's number one, because students might just end up here. You have to be careful because of this. Number two says we should find the force constant, the base unit of force constant. Okay? You know, for WAEC to ask this as a theory question, you need to be very careful. So force constant, I remember the Hooke's law. The force constant is K. It's denoted by K. So if I can remember the Hooke's law, that F is equal to KE, where K is the force constant, E is the extension, and F is force. So if I make K subject of the formula, because before you can find the unit, you need to make it the subject of the formula. So K is equal to F over E. F, the unit of F is Newton. Extension has to do with the increase in the length when a load is attached to an elastic material. So length, it represents the length. So the extension is meter. So what are we going to do here? Break this Newton down. If you can remember, same thing we did here. So Newton is same thing as kilogram meters per second square. Now divided by meter, divided by this meter. So that will be kilogram meters per second square times 1 over meter. Meter will cancel meter, so the unit here is going to be kilogram per second square. This is going to be your answer. The first constant. Number 3 is the Planck's constant. So remember the Planck's constant. The Planck's constant, all about the energy of a photon. When light falls on metals, they tend to eject or release electron. Okay, so the energy of light or energy of a light that is incident and the body is given by this formula. So the Planck's constant, you can get this from, we use H to represent the Planck's constant. That E, energy, is equals to H times F. F is frequency. H is Planck's constant. E is energy. Now you need to know, how do I break the unit? Unit of energy is joule. Unit of frequency is hertz. And unit of H is what we are looking for. So make H subject of the formula. H becomes E all over F. Now we need to fix them. Joule is same as work, if you can remember. So this will be joule per. Now frequency, hertz. Yes, I would have written hertz. But hertz, we still need to break hertz down. Hertz simply represents per seconds. Okay? Because we can remember that frequency is 1 over period. Period is in seconds, so frequency should be 1 over seconds. So can I write joule is, that Planck's will now be joule over 1 over seconds, which will give us something as joule times seconds over 1, which is joule seconds. You don't stop here. Why? You don't stop here because joule is still not a base unit. So you need to break joule down. So how do I break joule down? Remember that joule is equivalent to work. Work is force times distance. So can I say force times distance? Joule. Force is Newton times distance, meter, then times seconds. You can remember, to break this down would be kilogram meters per second square, that is Newton, as we did here and here. So times meter times seconds. Seconds up, we cancel 1 second down, and what is remaining would be kilogram meter square per seconds, which is same as kilogram meter square per second. This is going to be the base unit. I believe this is very clear. All right, so we move to the last question. The last question simply says that the joule is equivalent to what? In fact, we just did something like this now. The joule is equivalent to which of the following? So this is WAEC question 2022. Okay, so we are given kilogram meter square per second, kilogram square meter per second square, kilogram meter square per second square, kilogram meters per second. So to solve, solution. Okay, so joule. Joule is same thing as the unit of work, which is force times distance. Force is Newton, which is mass times acceleration, that is force, then times distance. Mass is kilogram. Acceleration is meters per second square. Distance is meters. So this will be kilogram over 1 over 1. Meter times meter will give us meter square over second square, which is same as kilogram meter square per second square, which will make which of the option? Option C, right? Yeah, option C, the correct answer. Bye. All right, the question we have here says an object weighs 60.0 Newton in air, 48.2 Newton in a certain liquid X, and 44.9 Newton in water. Calculate the relative density of X. So solution. So this topic is drawn from WAEC past question from the topic relative density. So we have it that relative density of a substance, let's say of a substance, is density of that substance divided by density of water. Now, relative density of, let's say, a liquid is equal to upthrust in the liquid divided by upthrust in water. And what is upthrust? Upthrust simply means the difference in the weight when an object is immersed in a liquid. That upthrust is that force that will act upward on an object that is immersed in a liquid. And that upthrust is equal to the weight of the liquid displaced. So if, for example, a solid is immersed in a particular liquid, the upthrust in the liquid should be weight of that solid in air minus weight of that solid in the liquid. That should be the upthrust in liquid. Okay? Now, if the same body again is immersed in water, you know that the water will come up, the level of the water will come up. Let's say this is the level of the water initially, and an object is partly or fully immersed in it. The liquid will come up. So when we collect this liquid here and weigh this liquid, the weight of this liquid is equal to what? Upthrust. Now, how do we get the value of this upthrust? I can weigh this object in air without immersing it in a liquid, then insert it in a liquid and use this spring balance to weigh this object in the liquid. So you know that when an object is immersed in, let's say you are trying to pull out a container from a well, you're fetching water. While the container, the booger, is still in the well, you notice that it's going to be light until it comes out of the water. You now feel the heaviness of it. So the reason why it is lighter in the water is because the upthrust, there is an upthrust that is countering the weight. Okay? So because of this upthrust, let this W in liquid be the weight in liquid. Let this be the weight in air. So when you use the weight in air, which is heavier, to minus the weight in the liquid, you are going to get the upthrust. So upthrust in water should be weight in water, weight in air minus weight in water. This will give us the upthrust in water. So to solve this question quickly without waste of time, we are given weight in air. So weight in air as 48.2 Newton. No, sorry, as 60. Weight in air as 60 and 48.2 as weight in a liquid. So weight in liquid is equal to 48.2 Newton. And weight in water is equal to 44.9 Newton. So we're asked to find the relative density of liquid, which is equal to upthrust in liquid divided by upthrust in water. So the upthrust in liquid is going to be weight in air minus weight in liquid. That will give us the upthrust in liquid. Upthrust in water will be weight in air minus weight in water. Remember, the liquid is different from the water. Liquid like kerosene and so on, oil. Now, if we substitute, so our relative density finally is going to be RD is equal to weight in air is 60 minus weight in liquid, 48.2 divided by 60 minus 44.9. So our relative density here is going to be, so 60 minus 48.2 is going to give us 11.8 divided by 60 minus 44.9. That will give us 15.1. So our answer is going to be 11.8 divided by 15.1, and that will be 0.78. Relative density has no unit, so this should be the answer. Okay, so we move to the next question that says, state the law of flotation. State the law of flotation. So the law of flotation states that first, one thing you need to know about the law of flotation is this. One is that before an object can float, number one, the density of the liquid has to be equal or greater than the density. The average density of the liquid should be equal or greater than the density of the solid. Once the density of the solid that is immersed in the liquid is greater than the density of the liquid, it's going to sink. But if the two are equal, it's going to float. Okay, that's one. Then what about the weight? If the weight that solid, the weight the solid will displace, the weight of the liquid displaced has to be equal to the what? That is, the upthrust in the liquid has to be equal to the weight of that object for the object to float. This is what the law of flotation is all about. So the law of flotation states that, an object will float when it displaces equal weight of liquid when immersed in it. An object will float in a liquid when the object will displace equal weight of that liquid when the object is immersed, when immersed in the liquid. Or we can say an object will float in a liquid when its average density is equal or lower than or lesser than the density of the liquid. So this is what the law of flotation is all about. So we move to the next question. The next question says, a liquid of volume 2 meters cube is, and density, 1 times 10 raised to power 3 kilogram per meter cube. You know that 1.00 and 1 are the same. So 1 times 10 raised to power 3 kilogram per meter cube is mixed with this particular volume, 3 meter cube of another liquid, and of density 8 times 10 raised to power 3 kilogram per meter cube. Calculate the density of the mixture. Assume there is no chemical reaction. We solve. Solution. A liquid, you have a particular liquid. Now, let's say this is the liquid A and liquid B. So we are given the volume of the first one. Let me call it VA is 2 meter cube. And the density, rho A, is 1 times 10 raised to the power 3 is something as 1,000. Is mixed with another liquid. I called it liquid B. And the volume was given as VB as 3 meter cube, as you can see. And the density, rho B, as 8,000. 8 times 10 raised to the power 3 is 8,000 kilogram. Calculate the density of the mixture. So we are looking for the density of the mixture. Now, there's something you need to know. If you are given a particular mass, for example, mass of A, 4 gram, plus mass of B, 6 gram, you combine these two together and you pour them in a particular container. You notice that the quantity will increase and the mass will do what? Will increase. You have the two inside. The total mass here is going to be what? 10 gram. It works for mass, yes. Volume. When you get a volume of a liquid, look at this particular volume. And the second one, look at this volume. No, let me increase it. And we have the other one here. This is A, this is B. When you combine these two in another container, you notice that the volume is going to increase. If this volume is 4 and this volume is 6, when you combine them together, the volume will increase and this volume is going to be 10. It works for volume. Now, let's talk about, for example, you have kerosene of a particular density. This is a substance. And you have water of a particular density. If the density of kerosene is 4 and density of water is 10, and you combine these two together, the density is not going to be 10. Sorry, 4 and 6. Let me use this. The density is not going to be 10. You don't add density as such. The way we combine volume and mass. You cannot combine, because density of water is 1,000 and density of oil is 500. You now combine the two, the density becomes 1,500. No, it doesn't happen that way for density. Okay, so what are we going to do? Since we know that we can combine volume and mass, we can use this knowledge to do something. We can figure something out. Okay? You remember, density is mass over volume. So it means that the density of the mixture is going to be mass of mixture. Mass of mixture all over volume of mixture. And what will be mass of mixture? Mass of mixture can work out when I combine the two, which is mass of A plus mass of B. This liquid, I'll add it up, I'll get the mass of mixture. Volume of mixture is going to be volume of A plus volume of B. I think we have volume already. So the volume will be 2 plus 3. 2 plus 3 will give us 5. So volume of mixture, we've gotten that already, is going to be 2 plus 3, which is 5. Now, we're going to find mass. If you can remember that density is mass over volume, so which means that density of A is mass of A all over volume of A. With this, you can find mass of A. Density of A is 1000. Mass of A is what I'm looking for. Divided by volume of A is 2. Cross multiply, mass of A is 2000 kilogram. Same thing with B. Density of B is equal to mass of B divided by volume of B. Density of B is 800. Mass of B is what I am looking for. Volume of B is 3. Cross multiply, mass of B is going to be 2400 kilogram. Now, what will be the total mass now? Mass of mixture. Mass of mixture is now going to be mass of A plus mass of B, which will give us 2000 plus 2400. And that will give us 4400 kilogram. So with this, you can find the density of the mixture. So the density of the mixture is equal to mass of mixture, which is 4400 divided by volume of mixture. And volume of mixture is 5. So the density of the mixture is equal to 4400 divided by 5 will give us 880 kilogram per meter cube. So, and that is it. All right. So we move to the next question. Explain why ships are usually refilled with sand and water after they have been emptied of their cargo. Explain why ships are usually refilled with sand and water after they have been emptied of their cargo. Okay, solution. There's something you need to know about these ships. Sorry for giving you this kind of. This is not a ship. We are talking about ship, not boats. Okay? You know, when the ship is carrying load on it, when it is loaded, the ship is floating. It is floating. So which means that this ship is in equilibrium. It is stable in this liquid. When you now empty the ship by removing the cargoes, the loads, what do you think will happen? The upthrust on this ship, because for this ship to balance, remember that the upthrust must be equal to the weight. This is still the law of flotation. The upthrust from the liquid should be equal to the weight. That is, the weight of liquid displaced should be equal to the weight of the object. So for it to float. So when you now offload or you empty this cargo, you remove the cargo, you remove the load in it. The upthrust will be greater on this ship. So what do you think will happen? The ship will not be stable. It will just be like a ladder that is dropped on top of water. So because of this, in order to achieve this stability, you now need to refill with sand and water. So when you do this, you refill it, you are trying to maintain stability so that the weight of the ship can be equal to the upthrust. So what am I going to write? The question, explain why ships. So the reason, so they are refilled. So the answer here will be to maintain stability of the ship. The sand and water will balance, sorry, will add to the weight of the ship to balance the upthrust from the water in order to achieve stability. So that is it. So the major reason is to achieve equilibrium between the weight of the ship and its upthrust from the water. So when this happens, the ship becomes stable. I hope it is well understood.